Did ancient humans have better eyesight than us? Okay, quick question, and be honest. How many of you are watching this through glasses, or contacts, or with your phone held at a very specific distance from your face that you've worked out through years of painful trial and error? Because that's the one spot where things are almost sharp enough. Right. A lot of you. Now here's a number. Roughly 2.2 billion people on Earth currently have some form of vision impairment. 2.2 billion. That's more than the entire population of the planet 200 years ago, and the rates are climbing. Myopia, short-sightedness, has gone from affecting about 25% of the global population in the 1970s to somewhere between 35 and 50% today, depending on which study you're reading. In parts of East Asia, it's approaching 90% among young adults. Something is happening to human eyesight, something significant, something fast. And the obvious question, the one that should be sitting at the back of your mind right now, is, was it always like this? Did the person hunting across an open savanna 50,000 years ago squint at the horizon the way you're squinting at this screen? The answer is no, and the reasons why not are stranger, more uncomfortable, and more interesting than you probably expect. Let's be precise about what we're actually asking, because better eyesight can mean several different things, and they don't all have the same answer. There's visual acuity, the sharpness of the image your eye produces, the thing an optician measures when they ask you to read the bottom line of the chart, and you get to the third row and start confidently guessing. There's visual range, how well you see across distance versus up close. There's low light vision, how your eyes function when the sun goes down and there's nothing to turn on. There's motion detection, how quickly and accurately you track moving objects. And there's something broader and harder to measure, which is how your visual system integrates with everything else your brain is doing. Attention, pattern recognition, threat detection, in ways that go way beyond the raw optics. Ancient humans almost certainly had advantages in some of these categories, but probably not all of them. And the reasons why reveal something about the human visual system that is genuinely startling, not because ancient people were superhuman, but because our eyes are not just biological cameras recording whatever is in front of them. They are adaptive systems, shaped by what they're asked to do. And for 300,000 years, the human visual system was asked to do something radically different from what it's being asked to do right now. The gap between those two demands is where this whole story lives, and it's a bigger gap than you think. Start with myopia, because it's the most dramatic and the most well-documented place where modern human vision has diverged from what the evolutionary baseline looks like. Myopia, short-sightedness, the inability to focus clearly on distant objects, is caused by the eyeball being slightly too long from front to back. The image that should land on the retina lands in front of it instead. Things far away blur. Things close up stay sharp. And for most of human evolutionary history, being unable to see clearly at distance was, to put it gently, a significant survival problem. The lion that is blurry is the lion you don't run from in time. The cliff edge that is blurry is the one you don't see until you've already stepped off it. Natural selection, in other words, should have been aggressively eliminating myopia from the gene pool for hundreds of thousands of years. Anyone with significantly impaired distance vision in a hunter-gatherer environment had dramatically reduced survival odds. And yet here we are, 2.2 billion people. Blurry horizons, an optician industry worth about $160 billion globally. Something went wrong, or more precisely, something changed. The research that cracked this open came from a surprising direction. In the early 2000s, ophthalmologists began noticing a consistent pattern in studies of children raised in different environments. Children who spent significant time outdoors had dramatically lower rates of myopia than children who spent most of their time indoors. regardless of how much reading or screen time the indoor children were doing. Which was interesting because the prevailing assumption at the time was that close-up work, reading, screens, caused myopia by training the eye to focus near and losing its ability to focus far. That turned out to be partially wrong, or at least incomplete. The key variable wasn't close-up work. It was light, specifically bright outdoor light. Natural daylight is orders of magnitude brighter than even a well-lit indoor environment. On a bright day outside, you're receiving around 100,000 lux of light. In a typical indoor environment, you're getting maybe 300 to 500 lux. That's not a small difference. That's a factor of several hundred. And it turns out, bright light triggers the release of dopamine in the retina. Retinal dopamine, researchers discovered, plays a critical role in regulating eye growth. When dopamine levels are high, which happens in bright outdoor light, the eye grows more slowly and is less likely to elongate into the myopic shape. When dopamine levels are chronically low, which happens when you spend most of your time indoors under artificial light, the regulatory brake on eye growth loosens. The result is an epidemic of eyes that grew slightly wrong because the environment they developed in wasn't the environment the visual system was calibrated for. Professor Ian Morgan at the Australian National University, one of the leading researchers in this field, has estimated that children need roughly 3 hours of outdoor light per day to maintain normal eye development. 3 hours outside, in bright light. Every day, your average office worker in 2025 is not getting 3 hours of outdoor light per day. Neither was your average child in school. And the data shows it in the form of a global myopia curve that has been climbing steadily since industrialization moved human life progressively indoors, under artificial light, in front of close-up surfaces. Ancient humans were outside, not occasionally, essentially continuously, from birth to death, in an environment of bright, natural variable light. Their eyes developed under the conditions the visual system was actually designed for, which is one piece of the answer, but not all of it. Because visual acuity, the sharpness of the image itself, is only part of the story. And in some ways, it's the least interesting part. Consider what ancient humans were actually doing with their visual system: tracking animals across open ground, reading subtle changes in grass movement, broken stems, displaced soil, the way a particular patch of earth looks different when something heavy passed over it recently. Navigating terrain by starlight, identifying edible plants by minute differences in leaf shape and color. Reading weather from cloud formations on the horizon. Reading other people's intentions from micro-expressions across a fire. These are not tasks that require simply sharp vision. They require trained, practiced, attentively developed visual skills. The ability to notice what matters in a complex visual field, to filter signal from noise, to detect pattern against background. Dr. Gara Ranganath, a neuroscientist at the University of California, Davis, studying attention and memory, has described how the brain's visual processing is fundamentally shaped by what it learns to look for. The visual cortex doesn't passively receive information. It actively predicts, filters, and amplifies certain kinds of input based on what has been important in the past. An expert tracker isn't seeing more than you are in the literal sense. They're processing what they see completely differently, because decades of practice have literally rewired which signals get amplified and which get suppressed. Ancient hunter-gatherers weren't just people with good eyes. They were people who had spent every day of their lives developing a visual relationship with a complex natural environment that most modern humans have essentially no contact with. The difference between their vision and yours is partly biological, but it's at least as much about what the brain behind the eyes has been trained to do with what it receives. Different populations, different environments, different visual demands, and what it reveals about just how adaptable and how fragile the human visual system actually is. The Moken people, Southeast Asia, Noen, present day. The Moken are a semi-nomadic sea people of the Mergui archipelago, living across the coastal waters of Burma and Thailand. They are, or were until recently, essentially aquatic in their lifestyle. Fishing, diving, living on boats, spending the majority of their time on or in the sea. And the Moken children can see underwater, not metaphorically, literally. Where most humans lose about 2/3 of their visual acuity the moment they submerge, because the eye is designed to focus in air, and water has a different refractive index that throws the whole system off. Moken children diving without goggles maintain visual acuity roughly twice as sharp as European children doing the same thing. They can see clearly at depths where European children see blur. Anna Gislin, a researcher at Lund University in Sweden, who documented this in a study published in 2003, found that Moken children had learned, or rather, their visual systems had adapted, to constrict their pupils to the smallest diameter possible underwater, compensating for the refractive difference. This is a physiological response that most humans are theoretically capable of, but never develop, because we never need it. The really striking part of Gislin's research was the follow-up. She trained European children to do the same thing, and they could learn it. Within a few weeks of underwater practice, their underwater acuity improved significantly, approaching the Moken baseline. The capacity was always there. It just needed the environmental demand to activate it, which is a very specific and vivid illustration of a general principle. The human visual system has substantially more range than most modern humans ever access. Aboriginal Australians. Visual knowledge across 60,000 years. Aboriginal Australians have maintained a continuous relationship with the Australian landscape for at least 65,000 years, the longest unbroken cultural connection to a specific environment in human history. And that relationship is, among other things, a visual one of extraordinary depth. Researchers working with Aboriginal communities have documented what can only be described as a visual vocabulary for country, the ability to read landscape at a level of detail that trained European geologists and ecologists have consistently found humbling. Subtle variations in soil color that indicate underground water. Microchanges in vegetation pattern that signal seasonal shifts. The identification of individual animals across distance and terrain by movement pattern alone. This isn't supernatural. It's expertise. The product of a culture that has spent tens of thousands of years paying attention to a specific visual environment and developing, through that attention, a relationship with it that is simply unavailable to someone who grew up looking at ceilings. What it tells you about ancient human vision generally is that the baseline visual capability of the human system is much higher than most modern humans ever realize, because most modern people never put that system under the kind of sustained environmental demand that reveals its actual range, the high-altitude communities of the Himalayas and Andes. Here's a less obvious one. Populations living at high altitude, Tibetan communities, Andean peoples, have developed measurable differences in how their visual systems handle low oxygen environments. At altitude, the reduced oxygen can affect the tiny blood vessels supplying the retina and optic nerve. Over generations, high-altitude populations have developed physiological adaptations, differences in retinal vascular structure, different hemoglobin responses, that maintain visual function in conditions that would impair lowland populations. This is evolution happening in a visible documented time frame, not 300,000 years of gradual selection, but a few thousand years of environmental pressure producing measurable biological change in the visual system. The implication for the broader question is significant. If a few thousand years of consistent environmental demand can produce measurable visual adaptation, imagine what 300,000 years of consistent outdoor living in environments of bright light, open horizon, and complex natural terrain did to the baseline human visual system, the myopia tsunami in East Asia, 21st century. And then there's the most dramatic natural experiment currently running, right now, in real time. East Asian countries, particularly South Korea, China, Japan, Singapore, Taiwan, are experiencing myopia rates among young people that have no historical precedent anywhere on Earth. In Seoul, current estimates put myopia prevalence among young adults at around 96%. 96%. Essentially, every young person in the city is short-sighted. This is not genetics. The genetic profile of Korean or Chinese populations hasn't changed in a generation. What has changed is the environment. Extremely high academic pressure in South Korean and Chinese school systems keeps children indoors, at desks, under artificial light, for extraordinarily long hours from very young ages. The outdoor time that the developing visual system needs is simply not happening. And the eyes are responding, growing wrong. In a generation, South Korea has become so alarmed by this that eye clinics in Seoul now routinely prescribe outdoor time the way a doctor prescribes medication, literally. Go outside, 2 hours minimum. Every day. Come back in 6 months. The prescription pad of the 21st century, it turns out, is a park. Here's where the eyesight question stops being about optometry and starts being about something more uncomfortable. We tend to think about biological traits as fixed. You have the eyes you were born with. They do what they do. If they're not good enough, you get glasses. Which is fine, very practical, no complaints about glasses. Glasses are great. But the research on myopia, on Moken children, on high-altitude adaptation, on the visual expertise of people who spend their lives in complex natural environments, all of it is pointing at something that doesn't fit that framework. The human visual system is not a fixed camera. It is a developmental system that builds itself in response to the environment it finds itself in. And for the entirety of human evolutionary history, that environment was outdoors, complex, variable, bright, full of things at different distances requiring constant, active, wide-ranging visual engagement. The eye that develops in that environment is not the same eye that develops under fluorescent lighting in front of a screen 2 feet from your face. And here's the thing that should probably bother you more than it does. We are not talking about minor statistical differences. The myopia explosion in East Asia happened within a single generation. One generation of changed environmental conditions produced dramatically different visual outcomes in children whose genetic endowment was identical to their parents. The visual system is that responsive, that plastic, that dependent on environmental input to develop correctly. Which means the question, did ancient humans have better eyesight than us, has an answer that is more interesting and more troubling than a simple yes or no. Ancient humans had the same visual system we have, the same genetic potential, the same biological hardware. What they had, that we largely don't, is the environment that system was designed to develop inside. They spent their childhoods outside in bright light, tracking moving things across distance, navigating complex terrain, doing exactly what 300,000 years of selection had calibrated the human eye to do. Their eyes, developing in those conditions, became what the visual system is capable of becoming. A lot of ours, developing in offices and classrooms and bedrooms lit by screens, became something slightly less than that. Not because we are biologically inferior, because we changed the environment and the environment changed us back. The alarming part isn't that ancient humans could probably see better than many of us. The alarming part is that we could likely see much better than we do, and we are choosing collectively through the architecture of modern life not to. The capacity is still there. The Moken children proved it. The European children who learned to see underwater in 3 weeks proved it. The South Korean opticians writing prescriptions for park visits proved it. The eye wants to be used the way it was built to be used. It wants horizon. It wants distance. It wants complexity and variability, and the kind of light that only exists when you're actually outside under an actual sky. It will settle for the screen. It will adapt to the screen. But settling and thriving are not the same thing. And the eye knows the difference, even when we've stopped noticing. Go back to the beginning. The 2.2 billion people. The climbing curve. You watching this, on whatever device, at whatever distance you've learned, is the one that works. Here's what's strange about that number. It doesn't feel like an epidemic because it's so normal. Glasses are normal. Contact lenses are normal. Squinting at menus in dim restaurants is normal. Holding your phone closer and closer as the day goes on is normal. We've built an entire material culture, an entire industry, a whole aesthetic of frames and lenses and laser surgery, around managing a condition that is, on evolutionary timescales, extraordinarily recent and extraordinarily widespread. It's the kind of normal that only looks strange when you step back far enough. The person hunting across open grassland 50,000 years ago had eyes that had developed in the environment those eyes were built for. They weren't superhuman. They weren't some idealized prior version of us with sharper everything. They were just people whose visual systems had grown up outside, in the light, doing the things a human visual system is calibrated by 300,000 years of selection to do. And what the research keeps showing, from the children of the Moken to the streets of Seoul, is that given the right conditions, the human visual system is still capable of that. It hasn't forgotten how. It's just been asked to live somewhere else. The eye that scanned the savannah horizon at dawn is the same eye you're using right now. It just hasn't seen a horizon in a while. Maybe that's worth thinking about next time you're making a choice between staying in and going outside. Your eyes, whether you know it or not, already have a preference.